Okay. Our guest speaker today addresses two of Rotary International's areas of focus: supporting education and saving the environment, and in this case, by examining other environments. Very unique mission. Dr. Melissa Rice is an associate professor at planetary science at Western, where she is holding a joint appointment in geology department and the physics and astronomy department since 2014. Melissa received her PhD from the Department of Astrology at Cornell in 2012 and was a NASA Astrobiology Institute postdoctoral fellow at Caltech from 2012 to 2014. Her research focuses on sedimentology, stratigraphy, mineralogy of Mars. She is a participating scientist on the Mars Science Laboratory Curiosity rover and a co-investigator for the MASS-CAM-Z investigation for the Mars 2020 Perseverance Rover mission. What an impressive career and an exciting position to be part of the Mars exploration process. Melissa, welcome back to the Rotary Club of Bellingham, and you have the floor.
Well, thank you so much for having me. This is a really exciting time to be talking about this mission, which I'm hoping some of you caught the landing of last month on February 18th, was the day when we had our 7 minutes of terror, getting that rover from the top of Mars's atmosphere safely down to the surface. I was on pins and needles for sure. Thank you for giving me screen sharing privileges. I am going to go ahead and share my own slides just because I have a lot to go through here in a short amount of time and don't want to bother you all by saying next, next, next all the time. So let me get my slides up here because this is a very visual mission. I specifically work with the cameras, and I want to make sure that I'm able to share some of these first glimpses of a new location on Mars with you. Can somebody please confirm that you can see my screen?
Yes.
Thank you. Great. So Perseverance has been exploring the surface of Mars for 1 month now, and we actually haven't done very much exploring of Mars yet. We've mainly been exploring the rover itself. Once the rover travels all the way from the Earth to Mars, we need to spend about 3 months checking out every component of the rover, making sure everything survived the long journey to Mars, making sure everything is still functioning under Mars's very cold temperatures and very thin atmosphere. So I am not going to be able to show you that much in terms of new exciting science results, because what we've been doing in the past month on Mars is really just making sure that our rover is healthy and ready to go. But I will be able to show you some glimpses of the tantalizing surroundings that we will be exploring in the coming months and years ahead. So I wanted to start in telling you about this new journey on Mars by starting with the vision of Mars that humanity has had for most of our history. And that is Mars as a single dot of bright red light in the sky. And Mars is shown here as the brightest dot in the night sky. And this is really how all of our ancestors have known Mars. And it's good to keep this in perspective, how fast we are learning about this other world that's 100 million miles away. Even 100 years ago, this was the best view that humanity had of Mars. And this was a gigantic leap in our understanding to go from a single dot of light, no different from the other stars, to an actual sphere that had dark spots and light spots and a white cap at the pole, like our polar caps. And so Mars 100 years ago was just beginning to come into focus as not only an astronomical object, but as a world that might have rocks and geology and maybe even vegetation and other life forms. Now, in the past 60 years since the dawn of the space age, Mars has really come into focus as a world that has a rich geologic history. We now know that those dark splotches that astronomers first saw in those resolved images of Mars, those weren't forests or other vegetation. Those were places where dust was blowing around on a very dry, rocky surface. And those polar caps we now know are full of carbon dioxide ice, not water ice. But we know from images like these that show scars of ancient rivers flowing across the surface of Mars, that at some point in its past, there was liquid water here. At some point in Mars's past, the planet looked more like this. And when we say at some point in its past, we mean a really long time ago. Mars and the Earth are both about 4.5 billion years old. They formed at the same time. And we think Mars looked like this, the more Earth-like version with oceans and clouds and precipitation and rivers and lakes. This was what Mars might have looked like 3.5 billion years ago, around the same time when the Earth was just starting to develop its earliest life forms. Mars has been a more dry, desolate, barren planet like this for the majority of its history. But what we're most interested in is that early period in time when there was water on the surface, and we're interested in whether the rocks on Mars today preserve evidence for this water and evidence for any life forms that might have emerged and been thriving in these waters on Mars. That's what we're after. And these are the tools that NASA scientists and myself use to try and search for those clues of ancient life that might have been swimming in ancient lakes on Mars, that we have microfossils potentially preserved in the rocks on Mars today. So these are NASA's robot geologists. I got my start in graduate school working with the Spirit and Opportunity rovers, 2 twin rovers that look like the cute little guy on the left. And more recently, I've been working with the Curiosity rover, which is the big, beefy white rover on the right. And Perseverance looks very similar. You might expect that as each NASA mission has gotten bigger and bolder and beefier, that Perseverance, the most recent rover, should look something like this. It turns out that Perseverance is actually the exact same body as the Curiosity rover, which launched in 2012. So we don't have any transformer robot on Mars, but the mission that Perseverance has and all its instruments are vastly improved, and it's a totally new, ambitious set of goals that this rover is going to do, even though it looks a lot like its predecessor, Curiosity. So that's Curiosity on the left, Perseverance on the right. They look nearly identical from the outside, but their insides are totally different because they're made to do totally different things on Mars. These are the components of Perseverance that are brand new. And you'll see that there is a huge set of instruments on the end of the rover's arm. Just to give you a sense of scale here, that arm is 7 feet long. The rover itself is about 10 feet tall. So if this rover was sitting on a basketball court, it could reach that arm up and make a slam dunk, no problem. The instruments at the end of that arm, which we call the turret weighs 200 pounds and it's the size of a lawnmower. So this is a big, beefy set of instruments, and we can position that turret. The rover can reach out its arm and put that arm down on a piece of rock with millimeter precision. So it's a big suite of instruments that we can very precisely use to touch rocks exactly where we want to explore them. The big thing that's inside the rover is this sample caching system. And there's a big carousel, a wheel in the front of the rover that can spin around, and that wheel contains 47 different little tubes. And these tubes are specially designed to collect samples of rocks that the rover is going to extract with its arm from inside rocks on Mars and put into these special sample tubes. The rover is able to seal those tubes up hermetically seal them so they're completely separated from Mars's atmosphere. And the rover is then going to deposit them on the surface of Mars. So that's the big goal of this mission and the big thing we're doing that we've never done before. We have never brought rocks from Mars back to Earth. So this rover is going to, for the very first time, collect samples of rocks on Mars, put them in these very special sample tubes, leave them on Mars, and then NASA's next mission is going to Mars to pick them up and bring them back to Earth. Now, just grabbing some rocks and bringing them home doesn't sound like that big a deal, but it's something that has never been done, never even been attempted, because it is so difficult to get to Mars and land on Mars. And it is a next giant leap in technology to then send a rocket to Mars to launch away from Mars and come all the way back to Earth. We have to do the whole thing in reverse, and NASA has never attempted that before. The other big difference that I'm really excited about for Perseverance is that the rover has a sidekick. The rover is carrying a small helicopter on its belly. And next week, the rover is going to drop that helicopter down onto the ground, drive away from it, and the helicopter can spin up its rotors and fly. This is going to be the very first time any powered aircraft at all has ever flown in the atmosphere of another planet. NASA is calling this a Wright brothers moment for Mars, because this is the first time that any human-made craft is going to take off in another atmosphere. And this is really hard to do on Mars because the air is super thin. In order to get lift from an atmosphere that is 100 times less dense than the Earth's atmosphere, this little helicopter has to be super lightweight, and its blades have to be super long. Give you a sense of scale for this helicopter. The body of it, that cube that says NASA, that's about the size of an apple. And the blades are 4 feet across, tip to tip. So imagine an apple with helicopter blades that are longer than a yardstick. That's what the proportions of our helicopter are here. And again, this helicopter is going to start flying on Mars as soon as next week. What I'm personally and scientifically interested in are the cameras. This mission has more cameras than has ever been sent on a single spacecraft to another planet. There are a total of 23 cameras. And the 2 cameras that I work with are the 2 on the very top of the rover's head there, the ones that look like 2 eyes, right beneath the big Cyclops eyes. These 2 square eyes on the top of the rover, these are the highest resolution color zoom cameras that have ever been built. And I'll tell you a little bit about those. These 2 cameras, they are called Mastcam Z. That's the name of the instrument. And Mastcam is the mast camera. These are 2 cameras on the top of the rover's mast, on the rover's head. And the Z stands for zoom. So these are 2 cameras that have a powerful zoom capability. They can go from giving you wide angle photos to being like a telephoto lens, zooming way in to distant things on the surface. I've been involved with the development of these cameras since the instrument was first proposed in 2013. So it's been almost a decade to go from proposing to NASA that we build these cameras from the rover to now being able to operate and take pictures with these cameras on the surface of Mars for the first time. So Mastcam Z, these are designed to be the science eyes. And these are the cameras right when they were finished being built. They were built in San Diego at the Malin Space Science Systems Laboratory. And there's one of the engineers in the background in full clean room garb. We like to say we were wearing masks before they were cool when we were building these cameras. And my research group at Western Washington University, which has had about a dozen students work on this project over the course of its development, we've been working specifically with the color imaging capabilities. And what that means is that we have helped design and build the filter wheel that is in front of the camera's detector. And this filter wheel allows specific wavelengths of light to pass through. so that we can take pictures not only in the visible colors that your eyes can see, but in colors that are at longer wavelengths, that are beyond what the human eye is sensitive to. And Mars actually becomes a much more colorful place in those longer wavelengths, in near infrared wavelengths. And so we have specifically designed our camera's eyes to be sensitive to the colors of Mars. Because to your eyes or my eyes, Mars, pretty much everywhere you look, looks like some kind of shade of reddish, orangish brown. But to these cameras, Mars is going to look like a vibrant jungle, and we're going to be able to see many more shades of colors and with much more specificity. And here's a group of my students and I when we went down to see the cameras right after they were completed. You can see the 2 cameras and some of the engineers behind us in the clean room in the San Diego laboratory. And we went down and helped the team take about 100,000 test photos with the cameras here on Earth before they were launched to Mars. And one of those test photos was a picture of us. So here are the leads for the camera team in the clean room. This is a picture taken by the actual Mastcam Z cameras that are now taking pictures on Mars. I like to think of this picture as the cameras being born in the lab on Earth, opening their eyes for the first time and seeing their parents. And so only a few people are allowed in the clean room at a time. The majority of the camera team was being seen here through a window in the mirror that they're holding up. And I had to go back to Bellingham before they took this picture because I was teaching a class the next day. So they had me call in on Skype, and somebody held up my image on a computer screen on Skype. And if you look really carefully, you can see that that's me. I actually got in the photo twice because of all of the mirrors that were being used here. But this was all just leading up to the big event, which was launching to Mars. This happened on July 30th of last year. And it took the rover 7 months to travel from the surface of Earth all the way to the top of Mars's atmosphere. And after that 7 months of traveling through space, 100 million miles to go from Earth to Mars, it took only 7 minutes for that spacecraft to land on Mars, descending through Mars's atmosphere. And I'll just briefly talk you through how that happened, because it's really amazing. The spacecraft had to go from about 14,000 miles an hour, which was its interplanetary travel speed, to 2 miles an hour in order to very softly touch its wheels down on the surface. So the spacecraft, first of all, had to slow down really fast. And the way that it did that was with a supersonic parachute. This is a parachute about the size of your living room or bigger. And this slowed the spacecraft down as it was falling to the ground from about 13,000 miles an hour to 900 miles an hour. 900 miles an hour, that's a lot slower, but we still don't want to touch down on the surface at 900 miles an hour, or that will be not a soft landing, but what NASA calls a hard landing, which is a nice term for a crash. So to slow the rover down even further, the rover detaches from the parachute and lowers itself down with a series of rockets. It's essentially a jetpack that the rover is using to slow itself down and navigate to the specific landing site it's heading to on Mars. And once it reaches its landing site, the jetpack hovers above the ground and lowers the rover down on a series of tethers. These are nylon ropes that are called bridles, and this whole maneuver is called the sky crane. And the rover's wheels pop down, it lands on the surface, those tethers then detach, the sky crane flies away, and we all celebrate. There was the crew of engineers at the Jet Propulsion Lab. They were able to be here in person in their full masks and social distance. And the rest of us, we were scattered all over the world in our living rooms, watching and jumping up and down and cheering with whoever was home with us at the time. Usually we would have all been together at the Jet Propulsion Laboratory. And I'm hopeful that sometime later this fall, the entire team will be able to get together and celebrate and jump up and down as we were so far apart from each other when this happened last month. So as soon as the rover landed, it started sending us pictures of its journey. And it transmits those images to us through a network of satellite dishes that are scattered around the globe. These are called the Deep Space Network. It's a network of international receiver dishes that NASA runs, and it receives the data by way of a communication network that NASA has in place around Mars. And this is a collaboration with the European Space Agency. NASA and the European Space Agency have several satellites that are orbiting around Mars, and the rover on the surface of Mars actually communicates with this network of communication satellites around Mars. And it's those satellites around Mars that send the data back to Earth. And it's a tricky thing to talk to a rover on Mars because the time that it takes for those signals to travel between Earth and Mars, it depends on where the two planets are in their orbits around the sun. And sometimes that can be 5 minutes when the two planets are very closely aligned, but sometimes it can take 20 minutes just for the signal to travel between the two planets if they're far apart. So because it takes so long and we have to rely on this network of satellites and dishes to do our communication with the rover, we actually don't talk to the rover constantly. We are not operating the rover in real time. What we do is we send the rover a bundle of commands once a day. And the rover sends us a bunch of images at the end of its day. And so we look at those images while the rover is sleeping overnight, and we make a decision about what we want the rover to do tomorrow. And then we send the rover a full day's worth of its commands all at once. Otherwise, if we were trying to operate the rover, let's say with a joystick, we would have this 5 to 20 minute delay time. And it could be that the rover had driven over a cliff and we wouldn't even know it for 5 or 20 minutes later. So it's a tricky thing to operate a spacecraft this far away. And the other thing we have to keep in mind when we're controlling this rover on Mars is that the length of Mars's day is slightly different than the length of the Earth's day. A day on Mars is 24 hours and 40 minutes. So 40 minutes longer than the Earth day. And that sounds pretty close, all things considered, but that 40 minutes difference between an Earth day and a Mars day actually ends up being really annoying. What that means for me, as one of the scientists who's operating the rover, is that my sleep schedule shifts forward by about 40 minutes or an hour every day. And so this is just a screenshot of what my own calendar looked like for the first month of March. And you can see that I started in March going to sleep at 12:30, and then the next day, 1 p.m., and then 2 p.m. and 3 p.m. Every day, my day is shifting forward in order to match the schedule of the Mars day. Today, I woke up at noon, which was good timing for this. And tomorrow, I'll be waking up at 1 p.m. After that, 3 p.m. And by the end of the week, I'll be fully working the night shift. And then I'll cycle around through the clock again. This is called Mars time, and it's an exhausting way to live. And NASA understands that, so they only have us work on this schedule for the first 90 days, the first 3 months of the mission. And that's about as long as a human being can do this to their circadian rhythm without really becoming overexhausted and making bad decisions. It's also the length of time that a marriage can sustain 2 people in the household living on these vastly different schedules. So I'm in the midst of this, and if I say anything a little loopy, this is why. Okay, let's see some real images from Perseverance mission to Mars. We have, on the days following the landing, we started receiving a full series of images that the rover took with those 23 cameras during its landing event. It had a camera looking straight up at the parachute when it unfurled. And here's just a snapshot from that movie. You can go to NASA's YouTube site and see the full movie of all these images stitched together. But here's a snapshot right after that parachute had unfurled, and you can see there's a beautiful pattern. NASA challenged the public to decode what this pattern meant on the parachute. And it only took the internet about 6 hours to figure it out. It's a code that spells out "Dare Mighty Things," which is the slogan of NASA's Jet Propulsion Laboratory. After the parachute stage, we had the sky crane lowering the rover down. And that same camera that was looking up and taking pictures took this beautiful, really space age, sci-fi looking photo of the sky crane as it was lowering the rover down. You can see its 3 tethers there coming from the middle of the sky crane. And you can see what we call the umbilical cord, which was transferring power and communications from the sky crane and the rover. This is just a really bizarre looking photo, and we're looking straight up at Mars's sky. You can see how dusty Mars's sky is, and you can see the bright edge of the sun in the upper right. Now, the sky crane, after the rover landed, detached and flew away and crashed into the surface, and the rover actually took a picture of the plume of dust that was kicked up when that sky crane crashed into the surface. And the Perseverance Rover has a Twitter account, and here's the tweet about it. And then there were also cameras on the sky crane looking down at the rover as it was landing. This is a beautiful, clean, pristine image of the rover. The rover is already much dustier after being on Mars for a week now, but you can see that here's the rover with its camera mast, hasn't even popped up its head yet, and it's hovering right here about 2 feet above the surface. You can see from the swirly patterns that the rockets that were lowering this rover down were blowing the dust all over. And then the orbiters that are at Mars, that communication network that I was talking about, they were taking pictures of Perseverance as it was landing from space. And the HiRISE camera, which is on the Mars Reconnaissance Orbiter, caught this image in the act of the parachute with the little rover down at the end, slowly descending down to Mars. And then after the landing happened, that same camera took a picture of the ground on Mars and caught Perseverance on and all of the debris that it scattered around its landing site. And here's a color image taken from space of the rover on the ground. Now, the cameras that I work with, the Mastcam Zs, they took a 360-degree panorama on in the first week after landing. It took a couple of days for the rover to pop its head off, pop its head up and look around and check out and make sure that its cameras were okay to start taking pictures. And on day 3 of the mission, we took this beautiful 360-degree view of all the terrain around us. And with those zoom lenses, you can really zoom into some of the detail here. And I'm just going to show you one really cute rock off towards the horizon that we on the team are calling the harbor seal. It's an interesting rock that's sticking up. And this is what happens to rocks on Mars that have been sandblasted with dust and wind for the past billion years or so on the surface of Mars. They can get carved into these really stunning shapes. And here is the very first look from Perseverance from the surface. This is when the lens caps were still on its hazard cameras. And then after those lens caps popped off, we got a really beautiful color image of all of the rocks in front of us. And so what's next? We've been taking pictures from the landing site. We've been spending a lot of time checking out all of the components of the rover. Everything looks good to go. And the big thing that's going to be happening next week, before Perseverance starts driving around and really exploring its landing site, the big thing is the helicopter flight. So this is going to happen as soon as next Wednesday. Keep your eyes on the news. It should be a big splash when this thing takes off for the first time. But we've got flight paths sketched out. We have identified safe helicopter landing pads around our spot on Mars. And it's going to be about 1 month of the helicopter flying and taking images from above. And what I'm really excited about is Perseverance reaching out with its arm, which has a camera, turning that camera back on itself and taking a selfie with the helicopter flying nearby. Those images should be really spectacular, and this is going to pave the way for the next generation of Mars exploration. It's never been demonstrated that a spacecraft can fly and control itself in the atmosphere of Mars. But after this demonstration, the next mission to Mars might include a much larger aircraft that could really be used to explore faster than we can with our robots on the ground. So I'm going to leave this here, and thank you for your time. And hopefully we have a minute or two for questions.
We're in great shape on time. You have about 4 minutes for questions.
Melissa, this is Paul.
Hi,
There are
Paul.
other countries that are exploring Mars. Can you tell us a little bit about where they are compared to your progress? And congratulations, by the way.
Absolutely. This has been a fantastic year for Mars exploration in general. Perseverance was one of 3 missions that launched to Mars around the same time, and they all arrived to Mars around the same time. And that's really because the Earth and Mars, they come into close alignment every 2 years. And so when the 2 planets are in that close alignment, it's a lot faster and a lot cheaper to send spacecraft to Mars. So that's why all of the missions tend to go to Mars at the same time. So when Perseverance launched to Mars, it was within a few weeks of the United Arab Emirates launching their first mission to Mars, which is an orbiter called HOPE. And HOPE is at Mars now, orbiting around and taking some first images on Mars. And the Chinese Space Agency also launched a spacecraft to Mars, which has also arrived. That is a really exciting mission. Again, it's a first for China to send a mission to Mars. And that mission contains an orbiter, which is around Mars right now. And sometime early in the summer, in June or maybe July, that spacecraft is going to send a lander down to the surface of Mars, and then that's going to be a landing pad, and then a rover will drive off of that and start exploring. Now, the Chinese Space Agency, they aren't as transparent with all of their dates and details as NASA is, so I can't tell you much more about that. But when that happens, it should be big news sometime in June or July. And Perseverance is really an international mission as well. It is primarily a NASA mission, but we have contributions from the European Space Agency, from the UK Space Agency. We have team members who are with us from Russia, from Norway, from Spain, from the United Kingdom, from Australia, from Mexico. So we really have an international collaboration for Perseverance as well. And it's to that point where no single nation can really pull off a mission of this size and scope and complexity all by itself. So we have several instruments that are contributed by other space agencies.
Thank you.
I have a question.
Go for it.
My question is, when the rover lands and doing that detachment process, I guess there's items that are still floating around. Do those items, let's say, for example, if there's a crash, are those items recovered or just left there on Mars?
They are just left there as space litter. Yeah, we actually don't have any items that are left in orbit around Mars. All of the pieces end up falling to Mars and crashing. And with those powerful cameras that are in orbit around Mars, we were able to locate them in the images around the landing site. So yeah, these unfortunately can't be reused, unlike SpaceX's boosters, for example, that land back to Earth. And none of these are recoverable. But what I'm potentially excited about, once the rover starts driving, it might be that we drive by some of these pieces. And that would be really exciting for the NASA engineers to study how the different components that got the rover safely to the ground, how they actually survived their fall down to the surface. For example, we might drive by the heat shield over here onto the right and be able to look at the damage that was done to the heat shield as it was falling through the atmosphere. And the engineers can then use that to build a more robust heat shield for the next time around. So that's an interesting question. And every time we send a spacecraft to Mars, we end up with a cloud of debris around it.
Melissa, I had a question. You mentioned that the images from Mars are transmitted by satellites that surround Mars.
Yeah.
Those satellites have been there for tell us about those satellites. Where'd they come from?
Yeah, these satellites weren't sent to Mars specifically to be a communication network. Each one of these is its own mission that was sent to Mars with cameras and spectrometers and instruments to measure Mars's atmosphere. And so they each had their own science goals. And Mars Reconnaissance Orbiter, that has been at Mars since the mid-2000s. So it's an aging spacecraft now. It's more than 15 years old. The European Trace Gas Orbiter, that was a spacecraft that went to Mars just in the past couple of years. And we have another more recent spacecraft at Mars as well called MAVEN, which was sent to Mars to study its upper atmosphere. So these orbiters, 99% of the time, are doing their own mission, taking images of Mars, sending the data back. But when they pass overhead, above where Perseverance is, Perseverance can transmit its data to them, and then they send that data back to Earth. And there's about a 15-minute window every day when those orbiters are visible in the sky overhead. And so it's in those windows that we take advantage of those orbiters overhead. So we have 4 spacecraft total that we can communicate with. And some of them are newer, they have bigger band passes. From the newer ones, we can get about 1 gigabyte of data transmitted. And from the older ones, we can get about 50 megs transmitted.
But you can't go directly from the rover to the circling the space, the NASA network around the Earth.
We can. The rover does have a high gain antenna, but it can't transmit a very big bandwidth of data. So we can use that in a pinch, and we can use that to transmit when the orbiters aren't directly overhead. Usually what that does in the DTE, which is the direct to Earth communication, it just sends little pings saying, hey, I'm alive, hey, I'm alive. But if we want to transmit movies or full-size images, then we really need that communication network.
Thank you.
Okay, I'm afraid I need to bring this really outstanding program to a close. I want to thank Melissa. A big round of applause from everybody. Very interesting program. I assume that lots of people are very interested in this too. Thank you very much. And with that,
for Perseverance raw images, you will see the new images as they are downlinked via that communication network every day. NASA makes their images publicly available immediately, so you'll be able to follow along day to day and see some of those first images when the helicopter flies.
very good. Well, I agree with Chuck. Outstanding program.